Hello, hi everybody. So today we are going to study the next distribution, which is Poisson's distribution. Okay, so actually the Poisson's distribution is the limiting case of the binomial distribution. So in the previous lecture, we have studied binomial distribution. So under what circumstances we have to consider the Poisson distribution, and what is the probability distribution function for this Poisson distribution. Okay, so random variable, you write down please. Random variable x is said to be Poisson following Poisson distribution. Write down random variable x is said to follow Poisson distribution if the probability of x, if the probability of x, if the probability of x, if the probability of x is given as is given as p of x is equal to, is given as p of x is equal to, so here a random variable x is said to be said to follow Poisson distribution if the probability of x is given as p of x equal to x equal to e raised to e raised to minus m, e raised to minus m raised to x upon x factorial, where the values of x can be 0, 1, 2, 3 onwards. So from here you can guess the circumstances where this Poisson distribution is applicable. So here you write down m is called Poisson's parameter. So m is called Poisson's parameter. Okay, so I hope we need to understand on what circumstances we have to consider the Poisson distribution. So as we have seen the definition that the variable x is called Poisson's variate, or is said to be follow Poisson's distribution if the probability of x is given as the e raised to minus m, and m is the Poisson's parameter, and e raised to minus m raised to x upon x factorial, where the values of x can be 0, 1, 2, 3 onwards. Now we need to understand what are the cases or how the Poisson distribution is the limiting case of binomial distribution. So when we have the number of trials very large, Okay, so in binomial distribution, we have small n is equal to number of trials. So when the small n is very large, that is n tends to infinity, and the probability small p of the success is very small. Okay, so for example, 0.002, and n is going to be 10,000. So in this case, better use the Poisson distributions rather than the binomial distribution. So the two things we need to understand: n, the number of trials is very large; p, probability of success is very small. Okay, and m, which is called mean. So the Poisson's parameter is the mean of binomial distribution. So m is equal to n into p. So here we need to understand what is going to be m. So m is equal to n into p. So m, which is a Poisson's parameter, is actually the mean of binomial distribution, and in Poisson distribution, the mean and variance is same. So in binomial distribution, what we have, mean is np. In Poisson distribution, what we have, mean is np. In binomial distribution, we have variance is equal to npq. But in Poisson distribution, we have variance is equal to np. So this thing we need to understand what is in the binomial distribution and what is in the Poisson distribution. So in Poisson distribution, mean is equal to variance is equal to m. Okay, so you can write this. Okay, I'll show you. See, in Poisson distribution, we need to understand the following points: how Poisson distribution is the special or limiting case of the binomial distribution. So in Poisson distribution, n is the number of trials, which is infinitely large. Okay, and then p is the probability of success, which is very small, that is p tends to 0. Now the average success is finite, that is np is equal to m. So here this m is called parameter of Poisson distribution. So here m is called parameter of Poisson distribution. And the important thing that I told you in Poisson distribution is, here we have mean and variance same, which is m. So here we need to understand that mean and variance in Poisson distribution is going to be same. Okay, now let us try an example, or first we'll understand what is the applications or where this Poisson distribution is applied. So what are the cases where you can find the Poisson distribution? Okay, so when we have to apply the things that we need to understand as we have in binomial distribution. Okay, so the number of trials is infinitely large, then p is the probability of success, which is very small. Okay, then these probabilities p and q are mutually exclusive, that we know. In binomial distribution also we have seen that. Now the Poisson distribution is used in some of the cases that I'm going to tell you. Okay, so for example, if I consider the death due to any diseases, right now we are having uh, very coronavirus, the breakthrough of coronavirus. So these kinds of disease, like we can have heart attack, cancer, this deaths due to diseases. Okay, so here we have n is very large, so trial size is very large, and probability is very small. Okay, so in these cases we can use the Poisson distribution. Now we can think of the another example of accidents during a certain period. Okay, so this case, accidents during the certain period also follow the Poisson's distribution. Now we can also have an example of phone calls received at a particular telephone exchange or the customer care center. Okay, this also falls in the category of Poisson distribution. So these are the some of cases where you can think of the Poisson distribution. Again, there are many cases like cars passing at a particular point on road during a period of time. Then we can think of the printing mistakes, okay, on a page of a book. Okay, so these are some more cases where the probability is very small, probability of an event is very small, and the n, which is number of trials or number of observations, is very large. Okay, so in this case, we can have more the variable, which is random variable. It follows usually the Poisson distribution. So whenever you have certain types of examples, you can think of using the Poisson's distribution. Now we'll try some examples based on this Poisson distribution. Okay, so please write down the example. If the mean of Poisson distribution is 4, if the mean of Poisson distribution is 4, then then find then find probability of P of, you have to write in bracket, P of, there is probability of, in bracket, m minus 2 sigma, m minus 2 sigma less than x less than m plus 2 sigma. I'll repeat the question once again. Okay, if the mean of Poisson distribution is 4, then find probability P of m minus 2 sigma less than x less than m plus 2 sigma. Okay, so let us see the solution of this problem. So here we have the problem. If the mean of Poisson distribution is 4, then we have to find probability of m minus 2 sigma less than x less than m plus 2 sigma. So here what we know is we know that this x is a Poisson's variable. So let x be a Poisson variable, that is x follows Poisson distribution, and we have given that mean m is equal to 4. So using this information, we need to understand the remaining parameter. So you can see what we need is we need sigma and m. So here m is given. In Poisson distribution, we know that mean is same as variance. So we know variance is going to be 4. And so if variance is 4, we know that sigma, which is the standard notation for standard deviation, so sigma is going to be square root of variance. And hence we can calculate sigma. So we get sigma is equal to square root of 4, which is 2. So always we consider the positive square root. Now we get sigma is equal to 2. So here we have got m is equal to 4. We have got sigma is equal to 2. So we can find the probability which is required or which is asked in the question. Now consider the probability function for x. So it being a Poisson distribution or Poisson's variable, so we can have the probability function p of x is equal to e raised to minus x m raised to x upon x factorial. Here the value of m is going to be 4, and hence we can write probability of x is equal to x is equal to e raised to minus 4 4 raised to x upon x factorial, where the value of x is going to be 1 2 3 4 0 1 2 3 4 onwards. Now we want to find out the required probability, so we can think of the probability of m minus 2 sigma less than x less than m plus 2 sigma. So here sigma is going to be 2, so we have probability of 4 minus 4 less than x less than 4 plus 4. So we can have the probability of 0 less than x less than 8. Now, what are the values of x we will have? So, x always starts from 0, but in this case 0 is not included and it should be less than 8. So, we can have 1, 2, 3, 4, 5, 6 and uh, 7. We cannot have 8, we have the inequality less than 8. Now, we have the values of x from 1 to 7. So what we can do is we can find out the probability and add this all. So we can have probability of x is equal to 1 plus probability of x is equal to 2 plus probability so on so. And then last we can have probability of x equal to 7. Now here if I write in terms of the probability function, so we can have the probability of x is equal to 1 is e raised to minus 4 4 raised to 1 upon 1 factorial. Probability of x is equal to 2 e raised to minus 4 4 square upon 2 factorial and so onwards. Probability of x is equal to 7, so it is going to be e raised to minus 4 4 raised to 7 upon 4 factorial. So what we can do is we can have this e raised to minus 4 common. Okay, so if I consider e raised to minus 4 common, what is the expression I'll be having? E raised to minus 4 into bracket 4 upon 1 factorial, 4 square upon 2 factorial, 4 cube upon 3 factorial, 4 raised to 4 upon 4 factorial, 4 raised to 5 upon 5 factorial, 4 raised to 6 upon 6 factorial, 4 raised to 7 upon 7 factorial. So as I told you to be ready with your calculators. So in examination, the value of e raised to minus m will be given to you, whatever the value of m we can have. Okay, so m is the mean of Poisson distribution, which is also the variance of a Poisson distribution. So I want you to calculate this value quickly. Okay, calculate the value, but do not put in the chat. So I hope all of you are calculating this value. So I hope you might have got this value, and this value is going to be 0.93. So the problem was to find the probability of m minus 2 sigma less than x less than m plus 2 sigma, and this probability is 0.93. Okay, so I hope you have got this.